So, Chapter 17, Radioactivity and Nuclear Chemistry. The author opens with a story about having appendicitis, and this illustrates a use of radioactivity. Nuclear medicine. Radioactivity can be used to take pictures of the inside of your body without cutting you open. One of the tests for appendicitis is to give you, come on, pointer. Well, that's an issue. To give you a radioactively tagged isotope, and then your body, sends that all over the place. And if there's an infection in your appendix, that isotope will accumulate there, and it can be seen on an image. Sorry, I'm really distracted by this pointer. So what exactly is radioactivity? Radioactivity is the emission of tiny energetic particles by the nuclei of certain unstable atoms. So we have an illustration here of an atom with the nucleus, and this is representing the electron cloud. Some atoms are unstable, and so they will just spontaneously spit out a little piece of their nucleus. That particle that comes out is high in energy, and an atom that does that is said to be radioactive. The particles that come out, many of them can pass straight through matter, such as your skin or the wall, because they are such high energy. So radioactivity was discovered in 1896. I think this is an interesting story. You're not going to be tested on it. Becquerel hypothesized that the greenish glow observed in phosphorescence, some things phosphoresce, and so at night a rotting wood stump may glow in the dark, and that's because of phosphorescence. So these uranium-containing crystals did this, and his hypothesis was that this was due to X-rays, the emission of X-rays. And so he exposed these crystals to sunlight and put them on a photographic plate that was covered with a black cloth, so that light couldn't get it, but if these were X-rays, the X-rays could go through. And he put it in a dark drawer and let it be. So he saw a dark exposure on the plate where the crystals had been. And so he believed his hypothesis was correct because his little experiment supported that. He presented the results to the French Academy of Sciences. Well, further experimentation revealed that the dark exposure spot would form even when the crystals had not been exposed to light and were not glowing. So that meant that phosphorescence and X-rays were something different. They were separate. So he realized the crystals themselves were emitting something. It wasn't just like a glow-in-the-dark frisbee or something that glows when it's been exposed to light. The crystals were emitting the rays whether or not they'd been exposed to light. So he called these uranic rays because they came from these uranium crystals. You've probably heard of Marie Curie. She was one of the first women in France to pursue doctoral work, postgraduate work. She studied, she was looking for new elements. She discovered 2 new elements, looking for other things that emit uranic rays. She named one of them polonium, after Poland, and the other one she named radium because it has such a high level of radioactivity. She changed the name of uranic rays to radioactivity because she demonstrated that it wasn't just uranium compounds that did this. Radium used to be used in the paint on watches to actually glow in the dark, and I think that's where we get this idea that anything that's radioactive glows in the dark. Well, that's not actually true. Marie Curie, her husband Pierre, and Becquerel won the Nobel Prize in Physics in 1903 for their discovery of radioactivity. And she also won the Nobel Prize in Chemistry in 1911 for discovering those 2 new elements, polonium and radium. And there's a picture of her with her 2 daughters.